Dielectric polarization. In the diagram, in a non-polar dielectric molecule, center of negative charge coincides with the center of positive charge, and no electric field acts on this non-polar dielectric. That means external electric field vector E0 vector will be a null vector. Now, if an electric field is applied on the right hand side, an electric field E0 is acting, in that case center of positive charge of a molecule of polar dielectric on the right hand side, center of positive charge will be pulled in the direction of electric field, and center of negative charge will be pulled in the opposite direction of electric field. And this process is called dielectric polarization. When a non-polar dielectric is placed in an external electric field vector E0, when a non-polar dielectric is placed in an external electric field E0 vector, external electric field E0 vector, comma, the center of positive charge, under bracket due to positively charged protons, center of positive charge due to positively charged protons in the nucleus of a molecule of that non-polar dielectric. The center of positive charge due to positively charged protons in the nucleus of a molecule of the non-polar dielectric material, and the center of negative charge due to electron cloud, the center of positive charge due to positively charged protons in the nucleus of a molecule of the non-polar dielectric material will be pulled in the direction of the external electric field E0, in the direction of the external electric field E0. In the direction of external electric field E0. Vector E0, and the center of negative charge due to electron cloud surrounding the nucleus, will be pulled in a direction opposite to the external electric field. surrounding the nucleus will be pulled in a direction opposite to the external electric field. Opposite to the external electric field. Is zero. Hence, therefore, the two centers of positive charge and negative charge of a molecule of the dielectric material will be separated. The two centers of positive charge and negative charge, and the negative charge in the molecule of dielectric material will be separated, are separated in this way when it is placed in an external electric field. When a non-polar dielectric material is placed in an external electric field, in that case the two centers of positive charge and negative charge in the molecule of that dielectric will be separated. And this process of separation of the centers of positive charge and negative charge of the center of positive charge due to positively charged protons in the nucleus from the center of negative charge of a molecule of dielectric material. The center of negative charge of the molecule of a dielectric material due to application of an external electric field is called dielectric polarization. It's called dielectric due to the application of an external electric field. Due to the application of an external electric field due to application of an electric field on it is called dielectric polarization. Is called dielectric polarization. Dielectric polarization. So if we return to the diagram again, in the diagram on the left hand side we have non-polar dielectric, and that will be so this is called polarization. This process is called polarization, in which non-polar dielectric will be converted into polar dielectric. Non-polar dielectric will be converted into polar dielectric due to application of an electric field vector E0 on it. So in this case, what center of positive charge will be separated from the center of negative charge, and a tiny electric dipole moment will be induced in the dielectric, and this electric dipole moment will act from negative charge to positive charge. This is a dipole moment. And for nonpolar dielectric, there is no electric field, there is no dipole moment in it. So P equal to 0 for nonpolar dielectric, dipole moment small p equal to 0, and there is no dipole moment if no external electric field acts on it. And this process of separation of center of positive charge and negative charge due to application of an electric field is called dielectric polarization. Also, a tiny dipole moment is induced in the dielectric due to dielectric polarization. Tiny dipole moment is imparted to each molecule of dielectric, each molecule of the dielectric material in the presence of external electric field. The electric dipole moment of a nonpolar dielectric is 0, as mentioned earlier. When a nonpolar dielectric material, when a nonpolar dielectric material is placed in an external electric field, in an external electric field, in an electric field E0, E0, induced dipole moment, induced electric dipole moment so in the diagram, so this is a nonpolar dielectric in which center of negative charge coincides with the center of positive charge in the absence of any external electric field, and dipole moment P equal to 0. Electric field E0 is 0, and that's why dipole moment small p equal to 0. But the same dielectric material is placed in an electric field E0. In that case, center of positive charge will be separated from center of negative charge. And in this case, a dipole moment will be induced in each molecule of the dielectric. So here, electric field E0 is acting towards right. Center of positive charge will be pulled in the direction of electric field E0, and center of negative charge will be pulled in the opposite direction of the electric field E0. And dipole moment small p will be induced in each molecule of the polar dielectric material. Here, due to application of the external electric field, nonpolar dielectric material will be converted into polar dielectric. The induced electric dipole moment of each molecule of the dielectric, each molecule of the dielectric will be proportional to the permittivity of the surrounding medium, and the applied electric will be proportional to the both the applied electric field of field intensity E0, applied electric field of field intensity E0, and permittivity of the surrounding medium, that is epsilon. and electric permittivity of the surrounding medium. Therefore, P proportional epsilon 0 can also be proportional E0. Epsilon 0 is permittivity of free space in this case. So simultaneously we can write P proportional epsilon 0 E0. P equal a constant alpha epsilon 0 E0. This is the induced dipole moment. Tiny amount of induced dipole moment in each molecule of the dielectric in the presence of the electric field. So this is electric dipole moment or induced electric dipole moment. Induced dipole moment in the dielectric, induced dipole moment in each molecule of the dielectric placed in an electric field, placed in an electric field is zero. It should be induced dipole moment in each molecule of the dielectric placed in an electric field is zero. Now, capital P equal capital P equal n dot small p divided by capital V. N dot small p divided by capital V. So where small p is the induced dipole moment in each molecule of the dielectric material, V is the volume of the dielectric material, and N is the total number of atoms of the dielectric material. So capital P is equal to N small p divided by V, and capital P is what induced dipole moment per unit volume of the dielectric material, or induced dipole moment density. This is called electric dipole moment. Electric dipole moment density, electric dipole moment density, or electric electric dipole moment per unit volume of the material. Electric polarization, or it is also called electric polarization of the dielectric material. Electric dipole moment density or induced electric dipole moment per unit volume is also known as electric polarization of the dielectric material. Dielectric material of total volume capital V and total number of atoms in capital N. Number of atoms capital N, where small p equal dipole moment induced in each molecule of the dielectric material. dipole moment induced in each molecule, and its expression was explained earlier. Dipole moment induced in each atom or each molecule of the dielectric material due to electric polarization. Due to electric polarization. Now, if we draw the diagram of polar dielectric material in which center of positive charge, which is denoted by blue color, center of positive charge is separated from center of negative charge due to application of an electric field E0 towards right, and center of positive charge will be pulled in the direction of electric field E0, and center of negative charge will be pulled in the opposite direction of E0. In this case, they are separated, and an electric field will be acting from the center of positive charge to center of negative charge. This is exception, and effective electric field intensity is E, which acts towards right, means in the direction of applied electric field, and this electric field intensity which is acting in the opposite direction of external electric field E0, that is EP, is due to the dielectric polarization capital P. Induced electric field intensity, which acts in the opposite direction of the applied electric field E0, that means it acts from center of positive charge to center of negative charge, that means towards left, is given by EP is equal dielectric polarization divided by, that is capital P, divided by epsilon 0 permittivity. Capital P divided by epsilon 0, that means permittivity. And this electric field intensity due to polarization will be acting in the opposite direction of the applied electric field. It acts in the opposite direction of applied electric field, in the opposite direction of applied electric field E0. Applied electric field E0. Therefore, the effective Therefore, the effective electric field, that is net electric field in the polarized dielectric material, the effective electric field, the effective electric field intensity, the effective electric field intensity in the polarized dielectric material, which center of positive charge is separated from center of negative charge, in the polarized dielectric will be E equal E0 minus EP. E0 minus EP. That is the net or effective electric field intensity acting in the polarized dielectric material, which will be acting in the same direction of the applied electric field E0. That means vector E is parallel to vector E0. Also, E equal E0 divided by K. E0 divided by K. 0 divided by K. Where K is the dielectric constant of the dielectric material. K is the dielectric constant of the dielectric material.